So at the moment we've talked about what radians are, and we've looked at the first really useful practical application of them in terms of tidying things up, making it easier, which is arc length. When we talk about calculations on circles, arc lengths, circumferences, and arc lengths are one of the ones that are a bit more awkward to figure out. The other one that's more awkward to figure out is to do with the area of a circle. So we hopefully remember that the area of a whole circle is pi r squared, and the area of the slightly more awkward part of a circle here is if I have a sector. Now when I'm doing this in degrees, and you will have done this at GCSE, we know that the sector area is pi r squared, but it's only a fraction of pi r squared. We know that the whole circle here is 360, and we have a fraction of that, so our sector area is theta over 360 multiplied by pi r squared. And this is how we do sector area. Now, just like with the arc length, if I convert this from degrees into radians, then what we end up with is, instead of theta over 360, the full circle is now 2 pi. So I do theta over 2 pi times by pi r squared, and you'll see hopefully quite quickly that those pi's can cancel out. So what we end up with is theta over 2 times r squared, much simpler. And this is usually tidied up slightly, so you will more commonly see this is written as half of r squared theta, and this is the area of a sector when you're working in radians, when your angle is in radians. A lot like arc length, it just tidies up to a very simple thing, and you'll see the first section of the textbook does exactly this. It just reminds you, tells you rather, if we're using radians, it simplifies the stuff, and we end up with this formula: A equals half r squared theta. The pi bit just disappears, and that's it basically. There's nothing more complicated than that, just like with arc length. So the next thing we'll do is we'll have a look at a few examples, and then we'll look at the slightly more complicated thing we can do, which is calculate the area of a segment.